Here we asked to find an expression for the time where the excess of simple interest over compound interest is at its maximum. So what that means is that the simple interest, as you know, is given by this formula, 1 plus it. And then there is also an expression for compound interest, 1 plus I to the power of t. And the excess of simple interest over compound interest is just a difference. So this tells us how much this is bigger than this. And then we can call this f of t, because this is a function of time. So we want to find the time where this expression reaches a maximum. So all we have to do is just to apply your 1821 mathematics, and just to take the derivative and to find the maximum. And I'm going to make a slight modification. I'm going to change this to, it's not an equal sign. So I'm just going to change this to e to the power of delta t. And the reason why I'm doing this is because when I take the derivative, this is going to be a lot easier to handle. So taking the derivative with respect to t, this becomes I minus delta e to the power of delta t. And we'll let this be equal to 0. So we want to find the point where the slope is 0. So this gives us the maximum. So I over delta e to the power of delta t. So t is equal to 1 over delta natural log I over delta. So this is the answer. But there's one more thing that we need to check. So we know that at this point, the slope of the curve is 0. So it could be the case where it's actually a minimum. So in this case, the slope is also equal to 0. So what we need to do is that we need to check the second derivative. So taking the second derivative, this becomes 0. The e term over here becomes negative delta squared e to the power of delta t. So we know this is always larger than 0. An exponential term is always larger than 0. And because of the negative sign, so this term is always smaller than 0. It's always negative. So that's why we know that this curve gives us a maximum. So at this time it does indeed give us a maximum because the second derivative is smaller than 0. So it means the curve, if it's going up, it's going to become less and less steep. It's going to go to 0 and it's going to turn back down and it becomes steeper and steeper downwards. So that's what a negative second derivative means. So because of this, we know that the curve has to look something like this. And so that's why we know that this time over here gives us the maximum of this function over here, which is what we want.